Okay, so in your journal, we're going to go ahead and define these 6, and we're going to do some examples. Okay. What did you say, my dear? All right, a constant. Can anybody raise their hand to describe me what a constant is? It's a number without a variable. Like 5. Yeah. Why did this get closed? Sorry, buddy. Come on in.
All right, guys, let's head on back.
Okay. You guys cannot kick my doorstep out. Okay. Thank you for letting me know. Colin's the hero of the day. All right. Variable. I feel like you guys know this one. I have no clue. Amelia.
A letter that represents.
Ah. A letter that represents a number. Does that sound good? Out of here, return to.
It represents a messy number.
4. Right here. So put your pencil on. Okay. A letter that represents an unknown number or amount, however you want to say it. Now, Amelia, this is exactly what Amelia said. I just put the word unknown in there because typically it's going to be what we are solving for in this first unit. Okay. Now, a coefficient is a number, but where is this number?
It's in the equation. It's like to the like side of it, like you multiply.
The side of what is it?
Oh, it's basically a number on the bottom instead
The
of
side of on the side of a variable.
Okay, a number in front of a variable. Okay. Yes.
Actually, ask, like, isn't it also the same thing in science where they write it on the bottom instead of the top? Coefficient. It's basically for when you do science equations, instead of having it on top like the next exponent.
Not an exponent, not an exponent.
Instead
So this right here, 4x plus 1 equals 9. 4 is what we would consider the coefficient. X is our variable. 9 and 1 are both constants. Okay. If you want an example of what the heck I'm talking about, you could write that. What is the one thing an equation has?
Numbers.
an answer.
Well, this sometimes. Ha, an equal sign. Because its name is equation, has an equal sign. Okay, now somebody said an answer. It has an answer. Guess what? That's what we call a solution. So solution is just a fancy word for the answer. It's going to be a value that makes our equation true. Okay. So we're always gonna be able to check our answer because, or excuse me, our solution. We should be able to plug it back in and it works. Okay? Last set of words I want you to write down. Inverse operation. Operations that undo each other.
Undo operation.
Hey, and F, give me an example of two operations that undo each other.
0 and 0.
So, zero's a number, not an operation.
Okay, my bad.
0 plus 0.
Yes, Sophia. Addition and subtraction are inverse operations. Colin.
Multiplication, innovation.
Multiplication and division are inverse operations.
What about addition and division?
Not inverse. Not inverse from each other. They have inverse operations, but they're not from each other.
What about square root?
And what does a square root undo? A square, the squared exponent. Mhm. We'll get there later, all right? So here we go. With your highlighter. Highlight these two things right here. The addition property. If I have an equation, we can add the same number to both sides and we still have equality. Notice how A equals B, but I can add C to both sides and we're still okay. Why do I point this out? Well, if I have x minus 1 equals 7, we can add 1 to both sides to get our answer of yes, x equals 8. Why did I do this? I want x by itself. And we are subtracting 1. Well, how do I get rid of that subtract 1? We're going to do the inverse operation. So I'm going to add 1 to both sides. So Peyton, minus 1 plus 1, those go away. I have 7 plus 1, which is 8. So now I have x equals 8.
Okay.
Now, Peyton, what happens if we come back to here? Is 8 minus 1 equal to 7?
Yeah.
Cool. We solved it and we got it right.
Okay.
Okay. Peyton, should we do another one?
No.
Sure.
No.
Maybe I'll understand it. I don't know.
You understand?
No, I don't.
Next page, highlight these two things. Peyton, we'll be okay. We'll be okay. Let's look at this one. Highlight these two things right here. If we have an equation, we can subtract the same thing on both sides and we're okay. So basically, it's like a balancing act. If I subtract 2 from over here, I need to subtract 2 from over here so that we're balanced, okay? If I add 5 over here, I need to add 5 over here so we're balanced, okay? We're not changing the value of the equation, we're just changing the way that it looks, all right? So let me give you an example. Y plus 7 equals 9. Our variable is Y. I want to know what Y is, okay? Some of you know without showing any work. I get it, okay? But what is happening since we are adding 7 to y, and I want y by itself, we can do the inverse operation. So to get rid of this plus 7, we're going to subtract 7. And whatever I do to one side, I have to do to the other side. Okay? Peyton, are you okay with that?
Yeah, that makes a little more sense.
Okay, so now the 7 minus 7 goes away. And now y equals, what's 9 minus 7? There's our answer. Sam, do you have a question?
Do you want to show our work so that we know that we know how to solve it correctly, or
Yep.
so then we don't cheat?
A little bit of both. Okay, little bit of both. Okay. I want you to show your work so I know that it's your thoughts process. I want you to show your work so I know that you just didn't copy answers. Okay. Okay, so let's do this. Let's go to, do you see? Turn the page and there's some extra practice. I'm highlighting this for me. You don't need to highlight this. I want to look at number 1 and I want to look at number 4. Those are the two I want to look at. Okay, so this is what I'd like to have happen. I want you and your elbow partner to talk through number 1 and number 4 together and see if you can come up with an answer collectively showing your work. Ready, set, go.
So,
All right, Jenna. We're gonna work on, we're gonna do number 1 and number 4, but I want you to show your work. Okay. Kane's excited about algebra. Yeah, I love it. Keep going, keep going.
I thought.
Trust me, it works.
Oh, it does.
This is your 30-second warning. This is cool. I like it. Okay. Voices off. Eyes up here. Gus, for number 1, what do I do first?
-4.
Okay, Amy, why does he want to subtract 4 from each side?
Because you're adding 4.
Okay, awesome. Could you hear Amy? I don't think Peyton and Preston could because they were talking to each other. Amy said that Gus wanted to subtract 4 from both sides because 4 is being added to the W and we want W by itself. So since we're adding 4 to W, we want to subtract it to each side so that they go away and we have W equals what, Gus?
Well,
Thank you, Gus. Let's check our answer. Holden, is 12 plus 4 equal to 16? I love it. Okay, thank you. Number 4, Colin, what is our first move?
+5 and both sides.
Okay, we want to add 5 to both sides. Kane, why is he saying that that should be what we do? Okay, since we have Z minus 5 and we want Z by itself, we're going to add 5 to both sides so that that 5 is gone and we have Z equals 13. And we can check, is 13 minus 5 equal to 8? Perfect. All right, let's go back. Reverse. Oh, you don't even know what I'm referencing? That's, okay.
No, we're young.
I don't know.
Okay, let's go to the multiplication property of equality. Go ahead and highlight that for me. So we are back to page 5 in your journal. Okay. Okay. Now, this one says that if A equals B, we can multiply a number to both sides as long as you're not multiplying 0 to both sides, because then you get 0 equals 0, and that's just a big waste of time. Okay. It's not helpful though. So we can multiply a number to both sides to help us out. So let me give you an example of a time we would maybe need to do that. What if I had the equation x divided by 5 equals 2? I know that some of us can look at this and guess and check until we figure it out. But let's talk about, I'm giving us a simple one so that we understand when you get to like the more complicated ones. Do you see how x is being divided by 5?
No.
The inverse operation for division would be multiplication. So we can multiply both sides by 5. I don't know. Okay, so we have 5 times x divided by 5. Is just x. And then we have 2 times 5, which is 10. And Holden, is 10 divided by 5 equal to 2? Okay. You told me you knew it right away, so I just want to make sure that you're on the same page. What? Oh, do you? Okay. All right, so then last but certainly not least, we can do the same thing with division. We can divide both sides of the equation by a number to equal it out. Hang with me here, people. Hang with me. This is probably one that you will use a lot as we move throughout the chapter. Okay, when we get into multi-step equations, we're gonna have coefficients in front of x almost every time. Okay, so if we have 4 times x equals 12, well, 4 is being multiplied to x, and the inverse operation to multiply is divide. So if we divide both sides by 4, 4x divided by 4 gives us just x. X equals 3. You don't like it?
So he said he's like that. He's him.
Okay. Okay, so check in here. How's this feeling? Feel better. Let's do a couple problems with your partner. So let's turn the page one more time, and I'd like you to look at number 6, and I would like you to look at actually JK 7 and 9. Somebody did read my mind. 7 and 9. You have 1 minute to do them with your neighbor. 7 and 9.
Thank you, guys. Get all the work.
Okay. Amelia, what do we do for number 7? Okay, we're gonna have to divide both sides by 4. So B equals -13. Okay. Reagan, what about number 9? We need to multiply by -2 to get n equals 30. Okay, so let's talk about my expectations for your homework. First of all, raise your hand and tell me where you're going to use the problems to do in your notebook, Peyton. Okay, but where are the physical problems, okay? In Google Classroom, you need to reference the 1.1 book work. Where do you need to do them? On a piece of paper. When you come in on Monday, that notebook is open to those problems for me to check. Are you going to put answers or are you going to show your work?
Show your work.
You're going to show your work and you're going to have answers, yes. Are you going to know that your answers are correct? Yes, because you're going to check your answers. Okay. Yeah. 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 Oh, you guys, we have 2 minutes. I didn't realize that. Okay. I want to look at number 10. I thought we were at 36. I want to look at number 10. You know what? This is my fault. If you already put your journal away, just pay attention and you can always go back and fill in later. So just look up here. I'll read it to you. I'll even be that nice. A coupon subtract $17.95 from price P of a pair of headphones. You pay $71.80. Write an equation to figure out the original price of the headphones. Okay. What operation are we going to have? Addition, subtraction, multiplication, or division? I have a coupon that takes money off. Okay. Original price of the headphones, P. We subtract $17.95 from the price for a total of $71.80. So to solve, we will use our inverse operation. What? 75? Ladies and gentlemen, you will show your work. There will come a day where you don't have to show me +7 on both sides, but today's not that day. And next week's not going to be any of those days. Show your work. Have a wonderful weekend. Make good choices. Side by side. Does that make sense? It is. I'll keep that up here.